In a previous video, we set up a web application with a Postgres database managed by Hikari for the connection pool and Flyway for the schema migrations. Today we're going to create an API on top of it. So this will be JSON based and we're going to do it all TDD. We're going to write tests first, we're going to see them fail. We're going to create the API purely based on tests. Let's get started. Here we have our simple application. When we're running locally, we create an embedded Postgres and then we start the application. The application itself is a web server. There's no handlers on it. Everything will give us a 404 currently. This is the database setup and migration handling. So we can start adding a test. Here I have a class where we will first try to start and stop the application from a test. So we will need an application. The application needs a data source. We can get a data source with the embedded Postgres class. Just like that. Let's throw the exceptions. At the end of the test, we're going to close the app and we'll shut down the embedded data source. Right, let's prove that we can actually make a request at this application. So we use the built-in HTTP client. Just like that. We're also going to close that at the end. Okay, and to get a response, we're going to go client.send. We need to create a new HTTP request with the builder. The application has a URI endpoint. And let's just say we're going to get a string back. And we can simply insert, we get a 200 back. Now we actually expect to see this test fail because there are no handlers on the web server. So we would expect a 404 from each endpoint. Let's just make sure that's what happens. And yes, you can see the failure here. We expected a 200, but it was a 404. Let's just make this test pass in the most simple way possible. We can simply add a handler like this. And let's just write anything to get the test to pass. Okay, cool. Our first passing test. Now, before I go further with this, let's refactor this a bit so we can have multiple tests running, and let's make sure those tests run fast. So the first thing, I want to put these in fields. Control-Alt-F, just like that, and we will initialize it in the constructor. There it is. Let's do the same for the application. Control-Alt-F, enter. Same for the client. Control-Alt-F, enter. Okay, good. We've got one little issue here. Let's run it with a try catch. If we can't start the Postgres, we'll fail the test. That is fine. And let's shut down all of these things in and after each method. Okay, let's make sure the test passes. Okay, very good. What happens if we have multiple tests? So let's put dummy names here. I'm going to delete this later, but let's just see if it works. Okay, you can see the first one has passed. Now it's preparing the second one. And already this is a little bit slow, right? Quite a long startup time, 400 milliseconds for a test. That is too slow. Let's make this faster. We do not need to create and destroy all of these on every test case. We can start at once and then shut them down right at the end. So let's make these static. Let's set these up in the static constructor. And let's shut it down only after everything is run, also in a static method. Okay, let's rerun that now. Okay, so still a bit of a slow startup, but once the first one is finished, 3 or 4 milliseconds per test, I'm happy with that. Okay, let's move on. Before I delete these, I don't like all this code here. Let's add a couple of helper methods and make this a bit more palatable. First of all, I want to extract the request building into a method. So let's call this request. Yep, replace them all. And let's create a request builder by passing in the URI. Okay. Next up, when we're sending something, we're going to always be using strings as the response body type. So let's stick this in a method, Control-Alt-M, and let's just call this send. Okay, let's replace all. And what we want to pass into send is the request builder. Just like this. Let's call it request, even though it is actually a builder. And now our test looks nice and simple. Okay, we're ready to start actually test driving our API design. Let's delete those. Bye-bye. The application we're going to make is a restaurant application. So we will have a JSON endpoint. We can send in a restaurant detail and we will add it to the database and we can query it back again. So let's start by creating a restaurant class, which we're going to use in our tests. I'm going to just declare the class right here. So a restaurant, and let's give it a UID and a name. That'll do for now. So in our test, let's rename this. We want to say that we can post a new restaurant and query it back. If we create a restaurant object like this, and what's a good name? Wappin Rolls. Okay. I want to send a request to the application's URL with an endpoint API v1 restaurants. Okay, and here we have a request builder. So let's say the content type is going to be application JSON. Let's also accept application JSON. Thank you, IntelliJ. And we're going to post the restaurant as a body. So we're going to send a string, and let's add a helper method to the restaurant to convert this into a JSON object. So we can simply make it a string. So we want it to look something like this, to JSON.toString. This will give us an org.json object. So let's create a method here. That's a JSON object. And we simply return a new JSON object. Yep, easy. So when we post this restaurant to this endpoint, we expect to get a 201 response. And we will also get the restaurant JSON back. So let's test that first. I'm going to run this test. Okay, and we expect it to fail. It's a 201. So let's start by defining a restaurant resource. We're going to use JAX-RS. So we create a new class, restaurant resource. We want to serve this from API v1 restaurants, because it's the version 1 of our API. Let's import that. Okay, and we're creating a post method. So this consumes application JSON. It produces application JSON, or it will anyway. And let's do exactly that. So thank you. Right, we need to move our restaurant record into our main source code folder. So we just have it sitting around here. Let's press F6 to move it. So I'm going to move it up a level. That'll do. Let's make it public. It's still in our test folder here, so we're going to move it up to our main folder. And now we can register this resource with our web server. We don't need this handler anymore. I'm going to delete it. So we create a REST handler, yes, just like that. And we pass it a new restaurant resource. Okay, what happens if we run this? We get an error. We need to return, actually not a restaurant, but a response, a Jakarta response. So let's return a response with the status code of 201. Let's just see what happens now. Okay, and it fails. We get 415. That is a media type not supported error, and this is because our web server does not know how to convert a restaurant from the JSON body into a Java object. We need to tell it how to do that. We can do this with a message body reader. Let's create one of those. That implements that exactly, yes. This reader supports restaurant types, so if the type is assignable from a restaurant, then we're good to go. When we read from, we want to read the input stream into a string, convert that to a JSON object, and then create a restaurant from that. So let's assume we're going to have a static method called from_JSON, and that is going to read a JSON object, and we can use a JSON tokener to read the entity stream. So let's create that. Let's create a new method. There it is. Okay, just like that. Okay, so the only other thing we need to do is say that this reader consumes application JSON, and now we can register this with our REST builder, just like that. And now let's see what happens. And our test has passed, but we're not testing very much. Just testing, we get a 201. So next up, the restaurant object we get back should be the same as what we sent in. So let's just assert that is the case. So if we create a restaurant from the JSON, which is received from the response body, it should be equal to the original restaurant. Let's try that. Again, we expect this to fail because we haven't implemented this part yet. So let's come back and make this pass now. All we need to do is return the restaurant so far untouched, but we'll get to that later, as the result body. And to do this, we need a message body writer. So let's make one of those. It's very similar to one of these. This thing produces application JSON, and it is a restaurant body writer. Implements that. Yes. And once again, if it's a restaurant class, we can deal with it. And to write it out, all we do is we get the entity stream, and we can, this is not the most efficient way, but it will work. We convert the restaurant to a JSON object, which convert that to a string, and we get the bytes. And once again, we need to register this. So let's add a custom writer, and let's see what happens. Okay, so let's take a second to look at what's happening here. We have created a restaurant object. We have sent it as JSON to this endpoint. The endpoint's returned a 201, and also the JSON of the object itself. Okay, we're not actually storing this in the database. So although this test passes, it doesn't really prove that this thing is working. So we could add more test code to make sure that we can query it back, and we will need to add this to a database to make this to pass. So let's get started on that. So this is the lookup response. We're going to send a request, and we're going to pass it the ID of the restaurant. Okay, we accept application JSON. So in this endpoint, we should get a 200 back, and we should be able to create a new restaurant from the returned JSON, just like that. Now, if I run this now, the test fails as expected. We get 404. Okay, so we need to add this new endpoint, which is a get to API v1 restaurant/ID. Let's do that. So this is a get endpoint, produces application JSON. And we are going to return a restaurant object from the path, which needs an ID. So let's specify the path as well. Right, we're going to extract the ID. Okay, and if I Alt-Enter on this, IntelliJ can help us add this parameter. So UUID. And now I need to look up into the database to load this. Okay, suddenly to make this test pass, we need a database. So I'm going to just return null so I can compile things. And we need to add a database table. In the previous video, we learned how to do this. We can just create a schema like this. It's a version schema file like 0001. And this is going to be called the create restaurant table. Let's create a table called restaurants. It's got an ID, which is the UID, which is the primary key. It's got a name, which is not null. Okay, that's all we need. Next up, we're going to create a restaurant database class. We are going to need a data source. Let's just call that DB. Let's pass it in, constructor injection. Final, of course. Okay, to make our test pass, we need two methods. We need to be able to insert a new restaurant and then look one up by ID. Let's create those real quick. And we're going to be throwing SQL exceptions all over the place. Okay, so let's get the connection. Let's try the resources, let's call it con. And we're going to prepare a statement. Go insert into restaurants. The ID and name. Two values. Okay. Now we're going to plug the values into the statement. So we just set an object at parameter 1 is the ID. And then the name is part 2. And then we're going to execute an update. Okay, nice. I'm going to do something similar for getting a single restaurant. Let's return a restaurant object. And we're going to pass in an ID. Real similar stuff again. Let's go about that time. And yes, we're going to select it like that. And we set the ID as the first parameter. And now we get the result set. So if there is a result, we're going to return a new restaurant object, which has the ID and the name. And I just need to cast this to UUID. Right, else, let's return null. Okay, now we can use this from our REST resource. Let's pop over there. So when we create a restaurant, well, first we need a reference to the restaurant database. So private final restaurant DB. Let's call that DB as well. Right, dependency injection again, all lovely. And let's just insert the restaurant. Okay, exceptions will result in 500s to the client. Very nice. Now let's look up the restaurant in this method. So we're going to use our DB to get. Now, if it's null, we're going to throw a not found exception. Okay, 404. Otherwise, we return the restaurant. Let's throw that exception and run our test. And here we need to pass in a restaurant DB. So we can create one of those. That needs a data source. We have the connection pool right there. Let's try again. Isn't that nice? So let's look at what we've got here. We have some very simple code. It all came only from what was required from the tests. Our restaurant resource is mostly annotations, which is going to help with our REST documentation and keeping things consistent. Our database code is really, really simple, really straightforward, very customizable. And our test is really quite nice in many ways. It is fully end-to-end. This test is easy to read. We could make it easier. We could refactor this to make it look even more like a domain-specific language. And it is really doing a lot. So it is testing that we deserialize objects correctly when we send them to the server. It's testing the server is receiving them on the correct endpoint. It's testing it's going into the database correctly. And then down here, this lookup is testing that things are coming back correct. So all the reverse of all of that. So can it load the data from the database? Can it hydrate it properly? Can it serialize it? And this is going to pick up bugs quickly anywhere. So let's say, for example, we had a bug where we were converting everything to uppercase when restoring data from the database. And this test picks it up immediately. And we can immediately see there's a problem with the name. So the error messages are very clear. The code is simple. And in my opinion, this is a great way to write simple REST services. We don't need anything big or fancy, just a bunch of simple code. We can have thorough end-to-end testing. We don't need to worry about mocking any frameworks. And we can have a lot of these tests. They're going to run in a few milliseconds each. We can have great confidence that this microservice works because all the tests almost are going to be end-to-end. Now there's a lot more we could have done here. We should add tests to make sure we get 400s back with nice error messages when invalid data is set. We could add authentication or more filter options, deletes, puts, patches, all of that. We can add more entities, but really it's just a repeat of what we've already done, step by step, building up with test-driven development. As always, the code is available at GitHub, link in the description. Happy hacking!